Section 1.1 is going to be over interval notation and set notation. So first, let's just go through a few things with bounded intervals. Bounded intervals can be bound two different ways. You can have a square bracket like we have here, or a rounded bracket like we have here. So basically, and you've seen some of this before in previous classes, if your endpoint is a filled in endpoint, sorry about that. If your endpoint is a filled in endpoint, then you will have a closed bracket. If you have an opened endpoint, then you will have a, as we call it, an open bracket or a rounded bracket. So you can have closed brackets on both sides for closed points on both sides, open on both sides, or you can have one of each. And so the inequality would be written as such right here, and we'll get more into that as we go through. So also, let's look at some unbounded intervals, and we'll look at examples of each, no worries. Unbounded intervals go to infinity, either on the right side or negative infinity on the left side. So this first one right here, we start with a closed circle, so we have a closed bracket, or that square bracket, and it goes on forever to the right. The second one has an open circle and goes on forever to the right. So if they go on forever, go on to infinity, infinity and negative infinity will always have that open bracket because you can't touch infinity. It's just something you can get very close to, so it's an open bracket. Now again, the closed circle gets a closed bracket, open circle gets an open bracket. Same thing here. We're going to negative infinity on both of these. We have closed on B, we have open on B, so we have a closed bracket and an open bracket. And then again here on the left, it's written as an inequality, which like I said before, we'll get more into that with some of our examples. Alright, so let's look at example 1. It says write each interval in interval notation. Okay, so that's what we were just looking at, was our interval notation. Our inequality right here, remember I said we would look back to these, our inequality goes from negative 2 less than or equal to x less than or equal to 3. So we start at negative 2 and we go up to 3. So our smallest number will always be on the left, our largest number will always be on the right. But right here with the negative 2, there's an equal sign, so there would be a closed circle. So we are going to have a closed bracket. Same on the 3. It was equal, so there would be a closed circle. There's a closed bracket. Also, make sure every single time you have an answer, I want you to highlight that answer. That is very, very important. If we do not have highlighted answers, we don't have answers. Alright, let's look at the next one. Let's look at B. X is greater than negative 1. This is going to be one of our unbounded intervals because it goes forever. So if I have x is greater than negative 1, well, negative 1 is going to be my smallest number, and it's going to go up to, well, it just says it's greater than, so that means it's going all the way up to infinity. Remember, infinity has an open bracket, and it does not say anything here about equal, so that would be an open circle, which is also an open bracket. Again, don't forget, highlighted answers are the only answers. So let's make sure we highlight that. Alright, let's go down to C. Now we're looking at a graph, which is what we kind of talked about at the very, very beginning there. Our smallest number here is negative 3, and it's a closed circle, so we're going to have that square bracket or closed bracket. Make sure you have a comma in between each time there also. And then we go all the way up to 4, and 4 has an open circle, so we are going to have an open bracket there. Make sure to highlight. Alright. D, another graph. This graph is going to be one of our unbounded graphs because it goes forever to the left. So if it goes forever to the left, that's going all the way to negative infinity. That infinity's not so great. There we go, that's better. So remember, infinity and negative infinity have an open bracket, and then we go all the way up to 3. 3 is the largest of the numbers shaded on this number line, so it goes on the right, and it's got a closed circle, so we're going to have a closed bracket. And there we go. Highlight our answer. Okay, so now let's move on. We're going to go to set builder notation. With set builder notation, it's basically writing our answers as the inequality with a set notation at the beginning. So if we have this graph, let's start with the graph on the bottom here. If we have this graph on the bottom, every single solitary thing is shaded except for A. Well, that's going to mean that X is not equal to A, but with set builder notation, sorry about that, set builder notation, we have also X and then that little line right there. And we'll describe what that line means in a second. So then going back to this first one, we have 2 different pieces. So in our set, we have 2 different pieces as well. X is less than A. It's also equal. So X is less than or equal to A, or X is greater than B. And then we have this, again, that little X with that line in it. So that's going to be on everything with your set. So the set of all real numbers, X, such that. So that little line just means such that. X is less than B. So that's how this one right here reads. So if you hear me read one of these through, that little line right there, that's where I'm getting such that from. Okay? Let's see if we can figure this out now. We are going to start with the set builder notation and see if we can graph this. So X such that 2 less than X is less than or equal to 5. Well, we're not going to write all kinds of numbers on our number line. I'm not going to make you include every single solitary number there, but between 2 and 5, there's not very many. So we're going to start with our smallest number there, which is 2, 3, 4, 5. Since there's not very many numbers, we can include all of our hash marks, per se, in between all of them. If you wanted to put the 6 there, you can put the 6 there. It's not a big deal. Okay, so on 2, it's just less than, it's not equal to, so that just means that we have an open circle there on 2. On 5, X is less than or equal to 5, so we have a closed circle on 5. Now, the X here is in between the 2 and the 5. So that means that our shading is in between the 2 and the 5 on the graph. Whereas this next one, the X is not in between. We have an OR for this one. So that means we're going to have 2 separate pieces. So let's look here. We've got X is less than or equal to 0, or X is greater than 4. So we have 0, 1, 2, 3, and 4. So on 0, X is less than or equal to 0. So it's equal. We have a closed circle. And it's less than. So that means we're going to shade over to the left. Make sure you put your arrow right there. Make sure you put your arrow. Very important. All right, now X is greater than 4. Well, if it's just greater, I'm going to have an open circle on 4, and I'm shading to the right because it is greater. One thing that I have forgotten to do that I preached to you a while ago not to forget is to highlight your answers. So we're going to go back up here and highlight that answer, and we're going to go right here and highlight this answer. Okay, a little quick highlight job there. All right, so let's see what else we can get into here. Example 3, write the set of numbers in set builder notation. Okay, so it's wanting us to write them in set builder notation. Where a while ago with example 2, we were coming out of set builder and going to a graph. So now we have words, the set of all integers greater than 5. Well, we need to know that integers is z. Now I'm sure you've probably seen it as a funny looking z, but we're just going to use a regular z. I draw a line through the middle of my z just to make sure it's not mistaken for a 2 or something like that. So we have our open bracket x such that, now it says the set of all integers greater than 5. So we have x is greater than 5, but you cannot forget that integer part there. So we need to say and x is included in the integers. So there's a lot of symbols here. It's like a new language. There's a lot of symbols here that mean different things. So over on the side right here, we've got z means integers. Included, that's going to be that funny looking e. All right, and then while we're here, not equal, that's just going to be an equal sign with a slash through it. Okay, so there again, make sure that you highlight your answer. And we have example B. So we have negative infinity to negative 1 or negative 1 to infinity. For this one, something specific I'd like for you to notice is that this left side stops at negative 1 and the right side starts at negative 1. So if I did not have these here, I would go all the way from negative infinity to positive infinity. But I stop at negative 1 because there's that open bracket on both sides right there. So if I were to graph this, sometimes things are easier when you see them visually. So if I were to graph this and I put a negative 1 right there in the middle, well, graphing just this first piece, I would have an open circle on negative 1, and then it goes all the way to negative infinity. So all of this is shaded with that arrow there. If I graph the second piece, we'll graph that in green, and I start at negative 1, I'm going to go all the way to positive infinity. Again, make sure your arrow is there. So it looks like from the graph, I'm including the everything, the whole thing, the whole graph, except for negative 1. So when we write that in set builder notation, we have x, don't forget our little bracket to open, x such that x is not equal to negative 1. So everything is included except that negative 1. And like I said, sometimes it's easier if you draw a graph and you can see things a little better. I'm not saying you have to draw a graph if it doesn't tell you to, but again, it just makes things easier sometimes. Okie doke. So that is going to be the end of 1.1. And you will have your homework posted to follow.